Hi guys! In this video we're going to be talking about section 3.3 and 3.4 of the Math Resource Guide. So in these sections we're going to be covering finding the first derivative and tangent lines. So if we continue on from the last video, the question as to how to find the slope of a certain point on a function remains. But now that we understand limits, we can discuss how a derivative is found. So what is a derivative? A derivative is just the value of a slope of the function at a certain point. So if we are looking for the derivative of this point on the graph that I have in pink, that would be called our derivative. So we can visualize this by drawing a tangent line, which is this pink line that I drew here. And we're going to draw that tangent line at the point, and we're going to see that the slope of the tangent line is actually the slope of the point. So how do we find the slope of the tangent line or the point? Well, we can look at the basic slope formula. So when we look at it, we find that the closer and closer we get to the pink dot, the more accurate the slope gets. So, for example, we have this pink dot right here, right? And that's the point we're trying to find. So let's say we're trying to find the slope of this point. And let's say we go over here. And that's what we use as our second point. So let's draw a line connecting these two dots. And that's what our slope looks like. Okay, now let's try and draw another dot. Let's put it right here. So let's draw another line, and we're going to connect these two points. And as you see, the closer and closer we get to this point, the more accurate this slope becomes. So we're getting closer and closer and closer until we get so close that it's actually going to be the same. So using the limit concept that we've learned, we can write that the slope is just equal to the limit as x2 approaches x1. So this is the pink point. The pink point is going to be x1. So here, I'll just write it like that. So the limit as x2 approaches x1, and we can see that because the closer and closer that we get on this side to that point, to the x1, the more and more accurate that slope gets. So we're trying to get as close as we possibly can to that point. So we write the limit as x2 approaches x1 equals, of y2 minus y1 over x2 minus x1. So now we can manipulate this equation, and I've written all of that down here, into what's called the definition of a derivative, which is at the bottom. And I suggest writing, at the very least, the definition of a derivative down. Now, I'm not going to go through this whole process, but feel free to write it all down if you want. Now, the reason why I'm not going to go through and explain it is because there's a much more useful shortcut that's called the power rule. So the power rule basically just says that if a function equals x to the power of n, then the derivative of a function is going to be n times x to the power of n minus 1. So let's go through a few examples of this. So if we have the equation f of x equals x to the fourth, we can write f prime of x, or the derivative of x, equals 4x to the third. Now we'll keep going. F prime of x equals 50x to the 49th power. Oh, that was weird. Sorry. So now we continue the derivative of x to the power of negative 1/3. Well, let's write down negative 1 over 3. That's going to be our slope, or sorry, our n, right? And then we're just going to write x. And then x to the 1/3 minus 1 is going to be 4 over 3. No, sorry, negative 4 over 3. So let's continue on. F prime of x is equal to 9, because we're doing 3 times 3, x to the second. F prime of x is equal to, well, let's see, 2 times 1/2 is just going to be 1. So we're going to have x to the first power, which we can just write as x, plus, well, x to the first power, this is, so x to the first power would be what x is, right? So we're going to make it to where we write a 1. And then, so it would be 1 times x to the 0, which is the same thing as 1, so we're just going to leave that off, right? Because anything to the 0th power is 1. And then, as you can see, the minus 3 doesn't have an x, so we're going to leave that off, right? That's not going to be a part of the derivative. It gets dropped off. Okay, so what about this more complicated example? So I'm going to split up this fraction to make this more doable. So, actually, before I write it like that, I'm going to rewrite this function into 3x to the third over x squared minus 4x squared over x squared plus 6 over x squared. Okay? So now we're going to take the derivative of this. So it's going to be f prime of x equals, well, let's see. We can cross out x to the third, 3x to the third divided by x squared is going to be 3x, right? So actually, I'm going to make this a little bit easier, I'm just going to write down that. So 3x minus, well, x to the fourth, or 4x to the second, divided by x squared. These terms are going to cancel out, and we're going to get 4, plus, so 6 over x squared can also be written as x to the negative 2, because whenever you have a negative exponent, that just means you're going to put it at the bottom of a fraction, right? So we can rewrite this x squared as x to the negative second power. So now I'm going to write the derivative of this like up here, so that we have a little bit of space. So the derivative is going to be 3, because we have this exponent here, times x to the 0, which is just 1, minus, well, so there's not going to be, so since this is just a constant, there's no x value, we're going to leave that off, and then we're going to go plus the derivative of this, which would just be negative 2 times 6, so minus 12, x to the negative 3, because we're subtracting this value, right? So this is going to be the derivative of this function over here. So that was a little bit more of a complicated problem, but you can understand the concept of how you're doing this. So a question that they're going to ask you is to find the slope of a tangent line at a certain point when y equals x to the negative 1/2. So this is basically just asking you to find the derivative, because the slope of the tangent line is the derivative, if you remember. So we're going to just find the derivative of this function. So let's go. Y prime, which is another way to write the derivative, equals negative 1/2 x to the negative 3/2. Now, I'm going to simplify this a bit so we can actually see what's going on, solve it. So y prime equals negative 1/2, and we're going to put this term on the bottom. So x to the third, so square root x to the third. So that's how we write this, right? So that's just a more simplified way of solving it and understanding how we do that. So this is our derivative. But they're also going to ask you to find the equation of the tangent line. So find the equation. So how do we do that? Well, we're actually given our x value, so we can plug in 1 for x so that we can find the slope of this line. So let's plug in 1, so we get 1, negative 1/2, square root 1 to the third, and then we're just going to simplify that. So, until we get negative 1/2. So now we have to make this into an equation. So this is our slope. So the slope of the tangent line is going to be negative 1/2. So how do we get that into an equation? Well, we can use y minus y1 equals m, which is the slope, times x minus x1. So this is just the equation of a line. So we can just plug in our values. So we have y minus y1, which is just a 1, equals our slope, which is negative 1/2, times x minus our x1 is also 1. And then boom, you're done. That is your equation of a tangent line. So basically, again, just to go through it, you want to get the derivative, plug in your x value to get the slope at that point, and then use the slope in your equation line, and also the points to plug everything in, and then you're done. And you can simplify it if you want, but I don't think that's necessary. I'm not really sure how they grade that stuff, but you might have to simplify it into the y equals format. But I'm not going to do that right now because I assume you can do that on your own. So the last thing that they might ask you, which they have an example of, which I stole from the resource guide, is they're going to ask you to find the horizontal tangent lines. So in this question, there is the graph of y equals 1 over 3 times x to the third plus 4x squared plus 7x plus 10 has two horizontal tangent lines. Find the equation of these horizontal tangent lines. So the way we do this, well, first before we do this, we have to understand that a horizontal tangent line is when the derivative equals 0. So let's just imagine a graph, right? A horizontal line, it goes like that, right? So the slope of this line is going to equal 0. That's what a horizontal line is, right? So we're going to use that as our way to solve for this. So let's first start by taking the derivative of this function. So y prime, or the derivative, equals, well, let's see, 3 times 1/3 is going to be 1, so it's just going to be x squared plus 2 times 4 is 8 times x plus 1 times 7 is 7 times x to the 0, which is just 1. And then obviously the 10 drops out because there's no x there. So the next step we're going to do to find the the horizontal tangent line is to set the derivative equal to 0. So we're going to have 0 equals x squared plus 8x plus 7. Okay, and now how do we solve this? Well, I'm going to try and factor it. So we have the x's. So how do we factor this? Well, you're going to have the you're going to have the 7 times 1 plus and plus. So now we just have the thing where we are setting it equal to 0, so we set each of these these little equations, these in the parentheses, equal to 0, so 0 equals x plus 1, so x equals -1. 0 equals x plus 7, and x equals -7. So those are the x values of our horizontal tangent lines. So how do we get the equations of these horizontal tangent lines? Well, we're going to have to first we're going to have to find the y values, right? Because we need to have a point in order to solve. So you're going to plug in each of these x values into the original equation to get the y value. So to save time, I actually solved them out already. But you get these numbers just by plugging into the original equation. So the values that I got for this first x equals -1, my y equals, this is also going to be your equation. So your equation is x y equals 6 2/3. And for the second one, which is the x equals -7, y equals 42 2/3. So these are your equations for the horizontal tangent lines. Thank you for watching. I hope this was helpful, and if you have any questions, I'm sure a few of your classmates can help you out. Bye.